to ISPT and welcome to our presentation on the results of our study for integration of a gigawatt scale electrolysis facility in industrial regions in the Netherlands. And this work has been an inter-regional cooperation with a lot of participation from many stakeholders in the field. And we are very proud to present our results with you today. Next slide, please. So before we start, can we see the next slide, Leah? Before we start, and to make sure that we all will have a nice experience, I'm sure by now that you have seen enough of how this goes over the time. But still, if you are not having the word, please make sure your microphone is muted and your camera is off, so we all have a smooth connection. If possible, it is good to use your headset if you want to ask a question. And if you have questions, always feel free to enter your question in the chat, which you will find in the command button in the middle of the control, at the lower part of your control screen. The session will be technically supported and moderated by Leah Bauma, and at some point during the meeting, you will also have the opportunity to ask questions. If your questions are in the chat, we will pick a couple of ones that we think are very nice to ask to the panel, and we'll give you the opportunity to ask your question in person. So welcome, sit back and enjoy our presentation. Next slide, please. So I'm still waiting for the slide for one moment. So first of all, welcome to the Institute for Sustainable Process Technology. In ISPT, we are a partnership where we bring a lot of stakeholders together. We have an innovation agenda that is driven for industrial transition, and we are aiming for radical change, to change real life and making new technologies flourish. And I think the results that we'll be presenting today are a very good example of the way we work. We connect stakeholders, we work in many different sectors and fields, and multidisciplinary, and we build a trusted environment in which we can really go and figure out all the way into the depth of the details of difficult technologies with aim to stimulate breakthrough innovations. And I think today we are able to share with you a perfect example of that. Next slide, please. We have a little bit of delay in the operation of the slides here. Probably due to the internet connection. So this part that we present with you today is our results from our Hydrohub innovation program, in which we aim to bring green hydrogen to the environment. Next slide, please. And our program is aimed at bringing a connection to build a connection between large-scale renewables. In the Netherlands, we are situated ideally at the coast, close to large sources for renewable power. And to make the connection between this renewable power and the use of this renewable power in industrial applications, the question is how to do that. And for green hydrogen, we have to bring this match. Maybe one question for people to mute their microphone. Please make sure your microphone is off. To make this match, there's a large demand already currently in industrial use for hydrogen. And how to make this match is by doing the following. Next slide, please.
We have some lag here.
We are still delaying a little, experience a little bit of lag between the slides. So how to match these scales is to think about how to build very large-scale electrolysis facilities, industrial size. This scale can only be matched if you imagine how to reach gigawatts. And by now, you hear more and more news about gigawatt scale, but when we started this project two years ago, a bit more than 2 years ago, this was really something that was not really thought of yet, because at that point in time, electrolysis was some technology mostly known at a megawatt scale. If we go to the next slide, with this goal in mind to match these scales, we've set up a broad program under Hydrohub, where we look at the technologies and try to understand how technology can operate and function best, and to improve technologies, electrolysis, electrolyzers on a larger scale than bench scale. And this is our megawatt test center currently in development. But then if you understand single electrolyzers and you want to reach scale, you also have to understand how to build factories. And this is the gigawatt project. And from this gigawatt project, we will present results today. Finally, also we want to understand how this is going to work in practice. And for that, we will have also the high chain program with which we want to understand how the hydrogen economy will develop over time and enable industrial transition to a carbon emission-free future operation. Next slide, please. So in this current work that we present, we have considered what do you need to build a large-scale electrolyzer. First of all, you need to understand the technology, and that's what we do in the core of the project. But also you need to understand how this technology integrates in its setting. If you build a large-scale facility, you must make sure that power will arrive there, that you have water, but also that you have the infrastructure to connect that facility to the market, to the users. And our view there is, of course, an industrial one. But I think in broader sense, by now we have seen that there's an opportunity in the Netherlands to make use of offshore wind, and therefore our industrial clusters situated at the coast with a lot of infrastructure and port connectivity, also the logical places there to build these large-scale facilities. In this work, we have really zoomed in into these regions and look where can you put this kind of facility and what does it take to bring it there. Next slide, please. Clearly, this is not our single work. It is a work of a team. It's a really, really big team. We have done this with a lot of stakeholders across the Netherlands. We have organized sessions in each of these 5 industrial regions. And we have done this together with our partners, with the stakeholders on the ground, and with the local port authorities, with local provinces, with local industries, with many, many different stakeholders. We had really lively and enthusiastic discussions, because people start to imagine what does it take to bring this technology here. And this is what we are going to present and discuss with you today. Next slide, please. So clearly this is teamwork, and the team that has done a lot of the work to bring this all together in the report that we're going to share with you today is on the content. It has been brought together by the contractors that we have asked to support us. And these are from Royal Haskoning, the engineering company, from DNV specialist advisors on a lot of knowledge on infrastructure, power and on other technologies, and KWR, a specialist in water research. All this work also has been supervised by our project leader and our technical project lead, Peter Ripson and Hans van het Noord, and they've done a tremendous job organizing all the visiting workshops with all the local stakeholders across the Netherlands. So that is fine. You can carry on with the next slide. We have here for you today the public summary of all this work, and we will address some of the content of this public summary in a moment. The public report is for all of you to find in on our website or on our news items that we will share with you through LinkedIn and in other ways. And you can download and find all of the summary of the results in this public summary. Next slide, please. But before we kick off with the discussion, we want to share with you a short movie on the great enthusiasm that we've met along the way in bringing all of this together. Stel je voor en dan kun je. So with this, we're going to introduce our panel members first, and then we'll show some of the content that we brought together and discuss this with you.
Yeah, thank you, Andreas.
Yeah,
thank you, Andreas. This is Andreas ten Kaarte, our cluster director of the hydrogen program. My name is Carol. So welcome all. I'm responsible for the hydrogen program. But today we just saw our superstar from the movie. But now I would like to introduce you, our panel members today. Could you please put your camera on so the audience could see you? Thank you. So first we have our guest is Han Veenstra from the EZK, from the Netherlands government. Han? Yeah, he will coming soon from the camera. The second guest we have is Steven Engels from Ørsted, our wind power energy general manager. And then we also have here our hydrogen guru, Jörg Giggelen, and a movie star. Okay, so the fourth one, we have Ruud Melisten. Ruud, you also put your camera on so the audience can see you because he has a really nice background as well. And as last one, we have Tjeerd Jongsma, the director of ISPT. Welcome all.
Thank you.
Yeah, okay, good. Leah? Yeah. And next slide, please, Leah. It's a little bit lag today, I think. Yeah, it's a bit laggy. Yeah, it is we have now 105 participants today, so it is unfortunately cannot introduce you all of you and meeting you all. So I would like to ask you to scan the poll. It's an application which we can kind of answer the questions we have in the coming 2 sessions. Could you please scan the code and you will enter an app which you can vote for the questions I have for you. And Leah will also send you the link in the chat, which you can also click on your desktop if you're using that. The first poll question we have is, who is here today? Could you please answer that for us so we have an idea from this 100 of participants what kind of audience we have here? If you cannot find your public, please fill in others. A lot from industry, a lot of others. Knowledge Institute is also not so bad. No one from the government? I have network operators, means like infrastructure or tenant in this type of company. Wow, okay.
Well, it's excellent to see that we have a very strong industry participation. It's also really interesting to see we have quite some knowledge institutes. So I think we have leading innovators here together. And this is clearly our target audience, of course, today.
Exact, yeah.
But it's also nice to see that we have indeed also the government parties and the port authorities present.
Yeah. So I'm very glad to see, because this project, as Andreas just showed us, it's just really a good cooperation from different fields of the industry, government, and also all kinds of stakeholders which we need to make it happen. So welcome again, all of you. So from next, we could have another game before we start. Leah, could you please move to the next one? So we are really talking about gigawatt. It is basically a giga, like we say in Dutch, is a giga. It's really big and large. But how big is it? So I have a question for you to answer this question. How big do you think? Any answers are welcome. So don't be shy if your backyard is like that. Yeah. Oh, I would like to invite the 4% of people with the backyard. Yeah. Okay. Just a little bit in between. I would like to. I am very curious about our panel member. Maybe Stefan. What do you guess? Or what do you think?
I think it's 24 times a football pitch.
Okay, not your backyard.
No, unfortunately.
Ruud Meliste?
I think at least I need 24 more backyards.
Okay, good.
We should play soccer with you.
Yeah, we should go there. Good. I think now most people, they are voting for the 24 times of the football pitch. So I just learned from our project leader, Peter. So the pitch is only the grass field. That's for the ladies here. So it's not the whole stadium. So this is what I put it on. So it is a little bit smaller for the whole stadium. Let's see, get me the answer. I must say that a lot of people are having the right answer. So 24 of a football pitch. This is 67% of it. But also the Titanic is not doing very bad, and also the Eiffel Towers. The answer actually is, for the next, the answer is actually both are correct. We recalculated if the size is basically the first three answers are correct. And you can see here an overview. This is also the result we generated from our GigaWatt original studies. What you see here is basically the surface which we have combined for 4 cases. So extreme cases. So what you see on the left side, on the above side, is the maximum case of spot in the plot wise of the alkaline, which is combined about 17 hectares. So what you just guessed for the 24th football pitch is about that size, but also for the Titanic and also for the Eiffel Towers. So for that case, so that you can learn. And also on the right side, you have the PEM technology. For the most of you probably will know the PEM electrolyzer technology. Seems the stack is much smaller, but if you look at the plot here, you can see on the left side is a kind of black gray area, which is the electrical devices. It takes a lot of space. And the green one, this is not a motherboard, what people sometimes tell me, what you're showing me, Carol. This is the plot of a gigawatt electrolyzer. So what you see here, the green one, the field is actually the main electrolyzer plant. So the brown one is the electrical devices. And you'll see also the beige one, which is like a surface area, the facility like office. And the blue one is the water treatment for demi water and the wastewater treatment. So this is basically the 4 main area of the site. And on the left bottom under, you can see the minimal size from the plot, which is 10 hectares, is the alkaline technology if you're using. And for the smallest one that you can get is the 8 hectare plot which you have, and it is the PEM technology. Next slide, I would like to dive in how the slides look like. Leah, please, the next slide. So the smallest one is basically more than 10 times the football pitch. Yeah, so this is one of the pictures which gives you a little bit more in-depth about the maximum plot case of the alkaline. So I just explained the brown one is electrical devices, and then the green one is electrolyzers. If what you see on the lines is actually the cylinder form of the stacks, and also the separator from hydrogen and oxygen, and on the right side the water. So please, the next slide. A little bit of a lag, and also the utility you do see here. So for example, the oxygen. Yeah. So this is the example of the PEM. The minimum case means the smallest plot we can get. And the electrolyzer is a slightly different from the technology, for example, that you integrated the rectifier and the transformer within the setting of the electrolyzers. This is an example of it. Next slide, please. So really lucky today.
Just a bit slow.
Good. So some fact and figures, what you just have shown. So one of this stack That means a lot of cells, and you form one unit. We call it in the electrolyzer world is a stack. It's about 2 megawatts. This is the technology which you most common to get on the market. And per stack, you will stack them as a block. We call it also a train. So you combine these stacks together and you share, for example, the separator for oxygen and hydrogen. Then you have a kind of block. And combine many times of the blocks there, like a Lego blocks, then you get your total unit. For example, for the alkaline, you have 480. For the block, you have 60 about it, and within that is then times the stack. Then you have a 480 stacks together, which they combine, you get about a 1 gigawatt scale of a plant. And we can do the same for the PEM, but the PEM comes in a kind of triplet of a stack. If you do the same at 3 times the stack, and you have 2 megawatts, so about that number, you also stack up in a kind of adding up at numbers. So these are the numbers how we build up our plan to see how can we make that total of 1 gigawatt, and also the combination. You can vary to see what is the economic value about that. So next slide, please. Okay. I am very proud to say the project team did a great and fantastic job, and also with the stakeholders' input. So what we have tried to let you see for the next picture is actually the art impression. How does a gigawatt plant look like? So this is based on the state-of-art technology what we have today, and also is based on the alkaline design. So now we don't have lag. So this is the picture we have. So what you see is, of course, the wind park of Ørsted. I think, Stefan, is it your plan? So on the back, we have the offshore park. And also the plant, what you see here is basically on the left side is all the power electronics from transfer the power from the grid, from a tenant, for example, the 380 kV. And then we transfer to the plant on the right side. You see 3 blocks. The first 2 near the sea are the factories for the electrolyzers, and one of the third, we just cut open the roof so you can see what is inside. And this is the picture what I just tried to explain, that we have a kind of a block or train. So every unit of 8 of them are share one of the separation units. So and so on and so on. You just multiply them till a certain amount of capacity you need. And the next slide, just give you an impression based on one of the person here on the picture, how that looks like. This is just actually a kind of total big factory where you're looking at. And on the left side is basically only the water treatment. It is not really fancy, but you do need the space. And on the right side is the factory of the electrolyzers. Next slide, please. So I'll give you another picture just to feel how the plant looks like. Yeah. Now the leg again. Yeah. Yeah. And here is also another picture. On the left side is from the electrical, the travels, we call it. And then you can see the size what you need. It's a kind of a field for the power field, actually. And on the right side is the science, what is the side view. The side view of the factory. Then you get this rectifier and transformer on each side of the alkaline system. And for the PEM designs, it's just different is a system integrated, but this one is on the side. So this just give you an idea how it looks like. Yeah. Okay. So this is the idea how a gigawatt plant could look alike. So this is state of art how to call it, state of art impression. I have a question for Jörg. Jörg is basically in the same room, so I just turn my head a little bit. Jörg, basically I see a lot on LinkedIn. You are really the LinkedIn hydrogen king in this case. So you know a lot of this national hydrogen program. If you see this type size of plant, what do you think? Can we make the ambition to having the 3 and 4 gigawatts electrolyzer? Yeah.
Well, Carol, thank you for your question, and let me start by saying that I want to give compliments to the project team, because what started 1 or 2 years ago with just a faint idea turns out into reality. Because in the Netherlands, we have an ambition of 3 to 4 gigawatt in 2030. But I heard rumors that in the hydrogen strategy that will be presented by the European Commission next year, they think 3 to 4 gigawatt already in 2023. So that's in 3 to 4 years from now. So I think that you've shown a great vision of what can be done and what must be done. And while you were presenting, on the one hand, I was, when I read your draft report, I was shocked by the size of it. But on the other side, if you look at current fossil fuel activities like oil refineries or a coal-fired power plant, if you look at LNG terminal, that's also the same size. So what we're doing is on one hand, very, very challenging, but to our, let's say, energy and feedstock economy, it's also something that we're used to. I think the only big difference is that we still have quite a tough way to go to realize this, but this is the way to go for the energy transition. So again, I'm really impressed what you've done, and to make this really visual for everyone, so we can understand what hydrogen means for our energy system.
Thank you.
Carol, je staat nog op mute.
Yeah.
Yeah.
Sorry.
Yeah. To get to meeting this scale of size.
You really ask a question. I was sorry, the microphone was muted, so maybe you need to ask Steven.
Oh, Stefan, your phone is muted. Could you please open it again? I think we muted you.
We were muted. Yeah.
Yeah, it's open. But what's the question?
Did you get my question?
No.
Yeah, my question to you is, as an Ørsted, you have a lot of potential to giving us this green energy. And if you're looking at this gigawatt scale and ambition in the Netherlands, how do you think you will meet that, and how?
Yeah. Well, we think offshore wind is very complementary with hydrogen. First of all, because of our business cases, the offshore wind business cases, which need demand going forward in order to basically make sure that the business case is viable. Secondly, because we think it's a very good proposition to decarbonize the industry, which is going to be required if we want to decarbonize the economy. And ultimately, if we want to decarbonize industry, basically, conceptually, you could argue there's two requirements. First of all, the green hydrogen needs to be cost competitive. And secondly, we need to be able to provide baseload at the gate, basically. Once that's in place, I'm pretty convinced that the industry will be able to absorb large amounts. And in order to make it cost competitive, it's clear, and we've also seen that with offshore wind, that scale is king. And we need to be able to scale it in different steps in order to bring costs down. Therefore, we think we need to make these steps very soon towards 100, 200 megawatt kind of sites, potentially on site. But then it's clear that if we want to move bigger, these kind of hydrogen plants do not fit into an industrial site any longer because of the lack of flexibility in the underlying chemical process. So that's where we need to move towards more centralized production in this kind of gigawatt conversion parks. And I think that that's basically what's going to enable the energy transition to a very big extent, because it enables large-scale offshore wind construction on the one hand, and on the other hand, it enables the decarbonization of the industry on the other hand. So it's very complementary and it fits together.
Thank you. So you think you can make it? As I sound, the ambition is also there from Ørsted. Another question, your role as a partner in this gigawatt project, what does it bring to you as a partner?
Well, of course, it's a new endeavor to basically figure out how we're going to do that. And there's a lot of questions. There's technical questions, but there's also market model related questions and regulatory questions. So by bringing all the relevant parties together, we get a much better picture. Basically described in the report, on how such a gigawatt plan could look like, and also what the next steps are in order to get there.
Okay, so the stakeholders and also the road to get there from the gigawatt scale. Thank you, Stefan. I have the last question, if I may ask. Andreas is looking at me. I talk a lot, like always. Han, can I have you? I have one question to you. The last question here. As you've seen, this project is done with 26 of our partners. A lot of stakeholders. I think more than 200 companies participated in this work. How do you see that we can stimulate this cooperation in the 5 industrial area or cluster in the Netherlands more? Do you have an idea for us or suggestions?
Well, first of all, I want to echo Jörg and giving you my compliments on this project, because it really helps us to get an idea of what we're actually talking about when we talk about 3 or 4 gigawatt of electrolyzers.
Thank you.
And because so far it's just been a paper discussion, and this is for the first time I really get a feeling of what we're heading for. Okay. Secondly, sure, if we really want to make steps, then we have to involve a lot of stakeholders. And as we are all aware of, in the Netherlands, energy transition is very much related to the space we have, and what people want to do with this space. So obviously, it requires a lot of coordination. What I think will be very helpful here is that our ministry has started the Programma Energie Hoofdstructuur, kind of a program to decide on the main structure for the energy system. I'm not sure whether that's the proper English translation, but anyway, PHE, which how we call it, Programma Energie Hoofdstructuur, which will, I think, will be a very helpful tool in looking at spatial decisions on energy infrastructure from a system perspective, and to see should we decide in the Netherlands on, for example, on energy hubs where we for large-scale conversion, and what are the best and most suitable technologies, and how does it relate to the already existing infrastructure. So I think this program will be very helpful, and of course we'll look at it from a system perspective. Obviously, we also know that hydrogen will be part of the system. I mean, as was expressed in our recent hydrogen strategy from our government.
Yeah.
And I think one other aspect I would like to mention will also be helpful in bringing about this coordination. We will do a lot of research on the infrastructure. First of all, we have started the research on the hydrogen backbone, and that Highway 27 is the name of the project. And I think we had a kickoff meeting, it was 2 weeks ago already. Probably read about it in the press. And this will really help us to get a view about where are we going to use hydrogen, where do we want to transport it to, what kind of volumes are we talking about, what is the interrelationship with other technologies, with large-scale electrolyzers. So I think the input from this from your project will be very helpful for the further research we are doing on this topic.
Yes.
And I hope that maybe, as Jörg already mentioned, that this 3 or 4 gigawatt skill, maybe we can even reach that before 2030. But again, I mean, it also makes clear that we really have to think well about all the spatial implications, because, I mean, of course, in Corona times, you can talk about using football pitches, but after September, those football pitches will be used again.
It will be your backyard then, Han. Okay.
Yes. Actually, my backyard is a football pitch.
Oh wow! Okay.
Actually,
so
my backyard is one of the oldest football pitches of the Netherlands.
Good.
Okay.
Hey Han, thank you very much for your feedback. So I think we have a lot of questions also for you in the chat. So please read it also. If you can answer them, please. I don't have enough time to let the public ask you the question by person. So I give the word back to my colleague Andreas for the next results we are sharing. Thank you, Han. Nice, Stefan.
Yeah, thank you also, Han, because I think it's an excellent introduction to the next part of results. Next slide, please, Leah. Because actually, you're addressing a very important point. this is very nice to understand how big things can be. And of course, maybe a bit on purpose, but we have selected here the largest scale pitch. But the second part of our result is really looking at integration, really bringing it into the region. So if you want to draw the map of the Netherlands, which we did, where would you like to put these kind of things? And clearly this is a sensitive discussion. We've noticed throughout this exercise, space is an issue. There's not that much space available in the Netherlands, so you must be really picky. And if you really want to do this in industrial regions, what are sensible places to put it? And if you bring it there, how to hook it up? So I think you will appreciate that we've made an interactive map, which is visible on the website. And I do not recommend you to retype the URL, but rather just scan the QR code, or through the report, which you'll have in a PDF after this session, you can find the link as well. And you can play with this map yourself, because you can really zoom into the regions and then look at what we have investigated. And if you go to the next slide, then you can see an example. And just as an example, it's not per se because Ruud is here today, but we have zoomed in for a moment on Rotterdam. I'm waiting for the next slide. And there we are. Okay, so what we have done, and we've done this extensively in each of the regions, is to look, okay, if you consider your own plans of how you want to develop this region, which places would be adequate to put such facility? On the one hand, in terms of size, you must have the physical space, but also you need to connect it. And what do you still need to connect? So in Rotterdam, clearly the Tweede Maasvlakte, the outer area of the port is considered, and two spaces are indicated, and you see them as the black squares in the middle of the picture, and on the left-hand side as plots where this can be placed. And we've looked at connecting power, connecting water. What infrastructure do you need to hook up to the backbone? And for example, in Rotterdam, you need about 70 kilometers of gas piping. And if you go to the next slide, then you get a flavor of the kind of results that this has delivered. Because we've also looked, for example, at reuse of heat. So we looked at the locations, and in Rotterdam there are two. We looked at the possible hydrogen demand. Is there sufficient demand that if you install a gigawatt size factory, that you can bring it to the market and it will find its way there, it finds its use? And actually that is the case. And then also, if you look at the power connections there, but also how much hydrogen infrastructure do you need and what other facilities? And so by mapping out of this and understanding where we are in the Netherlands, if you go to the next slide, what we've seen and then is that across the Netherlands, we have roughly 22 locations identified in each of these industrial areas where these can be used. And in some places, there's a bit more suitability to reuse heat, for example, or to use the oxygen. So from site to site, we've looked at the regional variations of the possible use of the hydrogen, but also of the site products, all to make the position of this hydrogen as optimal as possible. And I think one message that also the pictures at the bottom show is that this has been a joint effort. We've done this all together with the stakeholders. And in each place, the facilities can be accommodated, the demand is sufficient, and the infrastructure is there. So not much is holding us back, except for the fact that we must figure out really how to build this. And I think that, for example, we've shown in plot sizes, there's room for improvement. And that's what we're working on. We're making more advanced designs to make the technology more compact and to make innovation work. But also we need to understand the requirements maybe a bit further and work with you in the area, in the ports and in the regions further to optimize our designs. And for that we will have a later point of view. But first now we also have Ruud Melister. In the call. Ruud, can you turn on your camera?
Yes. Yeah.
My camera is on.
Yeah, all the
Oh yeah, for me it's not always visible, but okay, there I see you with this. You have a sort of aura behind you. It's really beautiful.
There's a steam pipe.
Yeah. So Ruud, I think you've also witnessed some of the workshops that we've done in Rotterdam and the discussions, of course, that is brought about. And besides that, announcements are taking place everywhere, also in your region with BP and Nourion, for example. So maybe a challenging question. because there's competition out there. Will the first gigawatt factory be built in your region?
Of course.
Good question. Yeah, well, as a matter of fact, it's not so much about competition. It's about cooperation between the different clusters, of course, and we can help other clusters can help us, and we need more hydrogen than we can produce in our port, and that counts for more regions. So we make start now, and the start is very persuasive because of customers in our port that are already really investigating the possibilities into green hydrogen to replace existing gray hydrogen. And that is the reason why we are, when this would be a competition, that we can be ahead in this competition because of the fact that we already have so much hydrogen consumption and production. And you can easily replace that. Of course, it's not so easy when you look at the business case, but technically you can do a lot. And that's why we had a kickstart here. And this means
did this project play a role in making this discussion even more lively or enthusiastic? Was there was it a contribution there?
Yeah, absolutely. It is. This started off this project last year, I think. In the course of last year,
a year ago.
Yeah, in the course of last year, BP and Nourion already announced their project, the first quarter of a gigawatt, and lately Shell announced the next quarter of a gigawatt. So companies are following quickly and doing also their own studies. But it was for us as a port. This ISPT study was very important. Not only for us as a port, but also for our stakeholders who did this project together with us, Delta Links, the municipality, the province, state, because then you get a rough idea of what we are talking about here and what has to be done. And for us, during having these ideas, we already got these questions from the customers, and then it was really a short step to making a project organization. And a few of my colleagues, I counted 4 of them already, are in this meeting. These are project colleagues. They are actually doing a project on realizing a conversion park. So it's going very quickly. And
what we also did on purpose is to bring all the regions, of course, together, because I think we all have the same challenges. Like you said, it's not per se competing with each other. We have to beat climate change in the end. So did this partnership bring you also additional insights, learning from the other regions?
Of course, it does give additional insights. We learn from each other here. Important insights are about the utilities. What can you do with the oxygen? What can you do with the waste heat? How do you connect to the electricity? How do you connect to the hydrogen infrastructure? How can you cooperate there? So this kind of things are very important. Yeah, absolutely.
Okay. Great to hear your enthusiasm and support. I think for us, bringing all these partners together was challenging but satisfying. Maybe I'd like to go a little bit to Tjeerd for a moment, because as director of ISPT and with our mission to bring collaboration and partnerships together, maybe you can share from your viewpoint what this has brought ISPT as well, and through us, not ourselves, but our community, all of us.
Yes. First of all, of course, Andreas, congratulations with this excellent project. You brought you really did what our institute stands for, and that's bringing all the parties together. Because we see a lot of effort in all the regions all together, and this is the first time that things are really brought together. And I think it's very, very good to do that, to make it possible for the Netherlands to make the first step and take the first mover advantage of stepping into the hydrogen economy. And I think this project has really contributed to that. And then again, what was your question again, Andreas?
Well, I think you already kind of answered. The idea is basically our institute is about bringing people together, and we're trying to do that here. I think it is an example of what we're doing, but maybe it's also our mission and how we, where we're heading with this. And we try to do this in other places as well. So this is paving the way, basically. And what does it bring our institute and our partnerships?
Yes, it brings our institute that of course that we have a profile for the Netherlands as being the hydrogen country of Europe, and that's good for the institute. On the other hand, you also see that a lot of companies are really, well, they do not know how to move yet, and we see that everybody wants to have the first electrolyzer, but also the first electrolyzer has the biggest risks. And de-risking these electrolyzers together, I think it's that actually what brings this project also to the institute and to the Netherlands. And then we assess the risks of having the first one in a very good manner, as well in a societal way as on the scientific way in the other projects you run.
Yeah. I think it's indeed a very good point. Creating a common understanding of what are the opportunities, but also the risks is very, very important. Yep. I think we have an opportunity for one or two questions from the audience, also to the panel members in particular. Are there any questions that arrived in the chat, Leah, that we could share?
There are a lot of questions in the chat, so maybe someone has a burning question and raise the hand. Yeah.
The largest question I saw in the chat was that why aren't we building a skyscraper instead of a flat?
Exactly.
Yeah.
Exactly.
Whose question is? Let's see.
Harry was raising this question.
Hi. Yeah, I think basically it does exist. This the building of a department on layers on top of it. So basically it is possible, but how high is of course the question of the civil work and also the equipment. We did not, because what you just saw from the result from the team is basically the state of war. So the things what we have now. Yeah, the answer is it's possible. Thank you.
But I think more importantly, in our low scenario, we try to put two layers on top of each other of electrolyzers.
Yeah.
But if you imagine this is one electrolyzer to be the size of a bus, and then also the weight of a bus, and you put 200 of them on a floor, it's not that easy actually to get them all in place. So the question is, what is most economical?
Exactly.
And that depends a bit on the trade-off of how much space you have, whether you need to go up or not. And you can imagine there are places on Earth where there's plenty of space and where it's less. And actually, one of the challenges we have is to make a compact design. We may revisit this. So I think it's a very valid question.
Yeah, it's also the next step from the team.
I see, Ruud, you want to answer as well. Go ahead.
Yeah, because this space requirement that triggers me, because we are really we have a lot of space, but all this space already is occupied, and we built our second Maasvlakte and it's already almost sold out again, and we are not currently planning building a third Maasvlakte, and all this new sustainable energy costs a lot of space, of course. So I'm very interested in all this kind of concepts of multiflooring. And I remind myself of what we did with the pipeline system. We made in our port a multi-core, and it was a core of several pipelines close together that you could commercially lease out. And now I'm very interested in a multi-floor. So if you could help me with that.
Okay, point taken.
Maybe one other challenging question from the audience as a final opportunity to be heard. And someone wants to raise his or her hand. Leah, go ahead.
In the chat, there was a lively discussion about the configurations and the floors and so on, but no more questions I saw. So maybe someone raises.
Jörg has an option for us. I saw.
You have a suggestion, Jörg. Go ahead. Go ahead.
Now, Jörg.
It's in the chat.
It's in the chat, so you can
Okay,
read
speak up. Tell me.
I said we have to convert old diesel buses to mobile electrolyzers.
Maybe there's a new life for VDL. Take old buses and make them into electrolyzers. Well, let's see what is a smart way to move forward, but maybe a driving electrolyzer is not such a strange idea. I mean, make them mobile. Okay, but in all, what we're looking at gigawatt scale clearly is not a mobile solution. I think I want to thank the panel members for their contribution. I think I want to thank many more people, and we'll spend 2 more slides or so on that, and then we will come into an end of this session. So if we go to the next slide. First of all, clearly, once again, thank you all partners of the consortium for this tremendous work and for the support and for the ongoing work, because this project is not nearly finished. We're going on for 2 more years from here. Next slide, please. And of course, we have to wait a little bit. Clearly, this work has also been supported with the public funds of the TKI Energie en Industrie, who has given us a lot of support for this work. So I think that supports the public contributions. The work has also been carried out, as mentioned, by our contractors, with media support from Hartman Iking and Maarten Spoek, who have made the movie and who has contributed in the writing of the public report, but also featuring in our movie, which you can look at your leisure afterwards, our special guests from all the regions, but also from the grid operators of TenneT and GasUnie. And then finally, one more question, one more support. Thank you. In the next slide, please. A special thank you for all of our team members who've done a tremendous job in bringing all of this forward. And final slide. I really want to invite you to join us in the next step of this project. We will. You can frequently visit our website for results, reports, and other materials. But also, this has been a teaser maybe for a meeting that we will have by October. So we have a little bit of time to work on delays in slides and other small details, because we have really big important things to share with you. Looking at, for example, the cost of the electrolysis and more details on how to design this. We want to go onwards with you in discussions in bringing all of this beautiful technology into reality and change the world together. Thank you all, and let's move forward. Keep following us. Thank you.